Beyond deep space observation, the James Webb Space Telescope, JWST, is also revolutionizing our understanding of the planets within our own solar system. When it turned its gaze to Jupiter, the largest planet in our celestial neighborhood, the telescope revealed a mesmerizing display of auroras near its poles, intricate storm systems, and even faint, previously undetected rings. These features, captured in infrared with a clarity never before achieved, have provided scientists with unprecedented insights into the gas giant's atmospheric dynamics. The famous Great Red Spot, a centuries-old storm system, was observed radiating heat, and the surrounding cloud bands showed evidence of complex interactions between winds, magnetic fields, and chemical compositions. Jupiter, already a well-studied behemoth, suddenly appeared anew, more dynamic, volatile, and mysterious than we had ever realized. Following Jupiter, the telescope has turned its attention to Saturn, Uranus, and Neptune, planets often referred to as the ice giants. For Saturn, JWST detected subtle changes in its atmospheric bands and studied the planet's less prominent ring structures with fresh precision. These rings, made of icy particles, revealed hints of ongoing replenishment processes, possibly caused by moonlet collisions or meteor impacts. The telescope's observations of Uranus and Neptune were even more striking. For Uranus, JWST uncovered dramatic temperature variations in its upper atmosphere and hints of cloud activity that may help explain the planet's extreme axial tilt and peculiar seasonal patterns. Neptune's turbulent atmosphere, on the other hand, showed bright methane-rich storms forming and dissolving at astonishing speeds. Early data suggests new insights into their internal heat mechanisms, especially since Neptune emits far more heat than it receives from the Sun. Then there's Pluto. Although reclassified in 2006 as a dwarf planet, Pluto continues to captivate scientists and the public alike. When JWST focused on this icy world in the distant Kuiper belt, researchers were stunned to observe signs of complex seasonal changes. The telescope captured varying light reflections across Pluto's surface, suggesting that nitrogen and methane ices were shifting with the dwarf planet's slow orbit around the Sun. Even more surprising was the possible detection of subsurface oceans. Subtle spectral signatures hinted at pockets of liquid water beneath the frozen crust, raising the possibility of internal geothermal heat, possibly driven by radioactive decay or tidal forces from its largest moon, Charon. Surface activity, including apparent cryovolcanism, hinted that Pluto is not a frozen relic but an active, evolving world shaped by forces we are just beginning to understand. But JWST's mission doesn't stop with the planets and dwarf planets. The telescope is also uniquely equipped to study smaller bodies in the solar system, comets and asteroids, particularly those originating from the distant and largely unexplored Oort cloud or Kuiper belt. These icy wanderers are essentially frozen relics from the solar system's earliest moments, and they may hold the keys to understanding how water and organic molecules first arrived on Earth. JWST's infrared instruments are sensitive enough to detect the faint signatures of water vapor, carbon compounds, and other volatile chemicals escaping from comets, even when they are still far from the Sun. In one case, the telescope detected outgassing from a comet thought to be inactive, proving that even long-dormant objects may have hidden reservoirs of volatile material. This capacity to study pristine, unaltered materials from the dawn of the solar system could dramatically reshape our theories of planetary formation and the origins of life. Perhaps even more fascinating is JWST's ability to observe rogue planets, massive planetary bodies that drift through interstellar space untethered to any star. These so-called orphan planets challenge traditional definitions of what constitutes a planet. Some may have been ejected from their original systems by gravitational disruptions. Others may have formed in isolation. Thanks to the telescope's ultra-sensitive infrared vision, scientists have begun identifying the faint thermal signatures of these objects, revealing clues about their composition and structure. Even more intriguing, some rogue planets appear to have internal heat sources strong enough to maintain subsurface oceans beneath thick layers of ice. If confirmed, these worlds could be harboring microbial ecosystems in complete darkness, utterly disconnected from any starlight. This concept radically shifts our understanding of habitability and expands the realm of where life could exist. The implications of JWST's discoveries ripple far beyond planetary science or even astronomy. Each new revelation challenges long-held assumptions about the nature of planets, stars, galaxies, and life itself. Our theories of planetary formation are evolving in response to data that shows unexpected chemical reactions, bizarre orbital patterns, and the existence of previously unknown classes of celestial bodies. What once seemed like hard rules now appear as guidelines, flexible and ever-shifting. We're discovering that the processes that gave birth to our solar system may not be as unique as we thought, and that the ingredients for life may be scattered far more widely across the cosmos than we ever dared imagine. These discoveries are also helping redefine our understanding of time and scale. Many of the phenomena being observed, such as the formation of stars in distant galaxies or the drift of icy moons, take place over millions or even billions of years. Yet JWST is allowing us to see snapshots of these long-term events in action, as if flipping through a cosmic photo album. Each new observation becomes a puzzle piece in an ever-expanding mosaic, revealing not just how things are, but how they came to be. The universe, it turns out, is not just stranger than we imagined, it's stranger than we can imagine. Every unexpected discovery forces us to revisit the fundamentals and ask deeper questions. The telescope's mission, initially planned for a minimum of 10 years, is poised to last much longer. With ample fuel and stable engineering, JWST could continue delivering groundbreaking science well into the 2040s. Over time, the data collected will grow in scope and depth, enabling long-term studies of evolving systems and providing new opportunities for collaboration across the global scientific community. From exoplanet atmospheres to interstellar dust clouds, from galactic collisions to black hole environments, JWST is opening doors to questions we didn't even know how to ask just a few years ago. In a world filled with turbulence and uncertainty, the timing of JWST's launch and subsequent revelations feels almost poetic. At a moment when humanity is confronting immense challenges, from climate change to geopolitical instability, this telescope offers a shared vision of something larger than ourselves. It is a symbol of what can be achieved when nations collaborate in the name of science and exploration. JWST reminds us that our species is not bound by Earth. We are inherently curious, driven to reach beyond the limits of what we know. It speaks to a fundamental truth. We are explorers, born to seek out the unknown. And what of the search for life? JWST's examination of exoplanets such as K218b, TRAPPIST-1e, and others is pushing that boundary further than ever. In the atmosphere of K218b, JWST detected carbon-bearing molecules and water vapor, raising eyebrows and hopes. Further analysis hinted at dimethyl sulfide, a chemical that, on Earth, is primarily produced by biological processes. While not definitive proof of life, such markers are compelling leads. They prompt further investigation and sharper focus in future observations. Every molecule detected, every spectral fingerprint recorded, brings us one step closer to answering the most profound question of all: are we alone? As we wait for the next revelations from K218b and countless other worlds, we find ourselves standing on the brink of an intellectual revolution. It is an exhilarating time to be alive, a time when telescopes are not just instruments of science but instruments of wonder. They allow us to witness the invisible, to explore the unreachable, and to imagine the unimaginable. At Spaceloop, we're committed to bringing you the latest findings as this cosmic story unfolds. We believe that understanding the universe isn't just about facts and figures, it's about perspective, inspiration, and the joy of discovery. Because out there, among the stars, the next great mystery is always waiting. And with the James Webb Space Telescope lighting the way, our journey into the unknown has only just begun.